Hello, my name is Dave Strensky, and this is the first of a four-part set of videos to explain how to use the new supercomputer at University called Big Red 2. I've set up this demo. It's going to be in four different parts on different topics, and they're all going to have this same format. So I have two screens here. On the left, they're both logged into Big Red 2. The left is going to be where I'm going to be typing commands, and on the right here is where I have a kind of a notes file that will be part of the package, so you can basically follow along on the right and execute commands on the left, and I'll be capturing all the output into a log file, and you'll have all of this material so you can walk yourself through this demo by yourself anytime you want. So on the left here we have a directory. I'm logged into the machine already, and I'm going to go into this demo directory where I have some source files. Again, I'll be giving you a tar file of all this, and I'm going to start a script file that just kind of records all of the output. So when you first get on a machine, I actually just like to look at the message of the day. Usually if there's any kind of downtime or any kind of announcements, they'll be here. The beginning demo here is going to be just standard stuff from regular Unix commands. So here's host name, shows you it's login one. That's the name of the node that we're on, not particularly the name of the machine. We can get the name of the machine with, or at least the domain, with this command. I kind of like to do a who to kind of see who's on the machine, and also just gives me a sense of how busy the machine is. So there are quite a few people, and in fact if I do a who and pipe it into word count, so there's 54 people running on this machine. XT proc admin is a Cray command, and this will tell you information about all the nodes in the machine. Most of them are compute. You can see a couple of service nodes here. Most of everything is in batch. Looks like there's a couple of nodes that are unavailable for some reason. If you want to find out more information about this, you can do an xtproc -a, and this will give you more details about all the nodes in general. The output's quite wide, and so I've written a kind of a little filter here. So if you pipe that output into this rather complicated awk command, you'll just get the fields that are kind of important. So basically what this is saying, we can pick out a node here, and here's node 1037. This CNAME is the location in the machine, so it's in cabinet 1 of row 0, chassis 2, slot 6, and node 1. And if you look at the PowerPoint slides that go with this, that location will make a little more sense, and we'll talk about it a little bit later actually. This is a compute node. It has 32 cores, 64 gigabytes of memory, and it's running at 2.5 gigahertz. The -G option tells you more information about the GPUs that are in the machine, and again it has quite a wide output. You'll see that there's none here because these nodes are not GPU nodes, but these two are, so it'll only give you the extra output for the GPU nodes. We can again pipe that through a grep for Teslas, and so this will give us all the GPU nodes. And then if I put that through word count, it'll tell us that there are 676 GPU nodes in this machine. And then we can do this command again like before and pipe it into a filter. Just to kind of clean up the output a little bit. I'm going to roll back till I get to some GPU nodes. And this will tell you about the GPUs now. So the GPUs themselves have 5 gigabytes of memory on the GPU. They're running at 706 megahertz. They have 13 cores. They have a different name on the GPUs. I can't remember what they are, but 16 like blocks, execution blocks. They're kind of like cores. And these are the NVIDIA Keplers, the K20s. All right, XT notestat is another useful Cray command, and this gives you kind of a graphical picture of the machine. It actually rolled off. At the bottom of this output shows all the jobs that are running. That's what we're seeing here. But if we roll up a little bit, your machine is a 11 cabinet machine, and you can see this is cabinet 0 through cabinet 10, and the slots on the bottom are the slots, and then there's 3 chassis. So there's one chassis, there's another chassis, and there's a third chassis, and then there are 4 nodes per slot. So that CNAME, so and all these letters that are in here, I'm trying to pick out an example here. So here's a job, there's the user, there's the name of his job, and he's been giving the marker AA. So if I go and find, I can't find it. If I could find AA on this map, it would tell me exactly where that user, there he is. Nope. Anyways, if I could find him, it would tell me exactly where that user is, where that job is actually executing in the machine right now. So it's kind of useful, particularly if you're doing very sensitive kind of jobs. All right, so let's move on to modules. Modules list is, this is open source, kind of standard code. Module list tells me all the modules that are currently loaded. Some of the more interesting ones is this one here. Cray sets up a programming environment so that you can just switch modules and switch between Cray compilers or Intel compilers or PGI compilers. This module here tells that we're running on Interlagos processors. And we also have the Cray MPI that's loaded. And we also have the Moab and Torque scheduler loaded. Module avail, so this is what's currently loaded for my session. And if I do a module avail, it's a much longer list, and this tells me everything that's available on the machine. And you can find applications like Amber, games. So this makes it very easy. So if you want to run Amber, you just load that module, and then all of your paths should be changed so that you can find all the executables very easily. Here I saw CMake. That can be useful. And then if you're a developer and you want to do like FFTs, there should be like FFT, here it is, an FFT module. And so again, this is, you shouldn't have to do a lot of searching for applications or libraries. They should just be in this module avail list, and you just load the module and it goes. So I said that we currently have, if I do another module list here, we currently have the Cray programming environment loaded. And if I want to switch between the Cray compiler and the PGI compiler, I can do it in one shot with that command. And so that says swap Cray with PGI, or I can do it in 2 commands. I can unload something, and then I can load something else. Alrighty. PWD just tells you where you're at. That's my home directory. And you can do stuff like this. You can see what your what's in your home directory. And then there's also this other directory. We're not going to use it too much for this demo, but this is a Lustre file system. So you have your own home directory system, and then you have a much larger Lustre file system. And if you're doing some big science, that's where you want to be, because that has a lot more space. If I do a df command, you can see I've been told that DC2 is the Lustre file system, and it has on the order of 700 terabytes of, nope, it has 3.5 petabytes of disk space out there, so that's a lot of disk space. It's 20% used. So this is definitely where you want to be. And you should have a directory. Throughout this demo, I'll be using, I didn't want to make it tied to my user ID, so instead of uh, using ndc2 scratch my user ID, I just put this environment variable, and you can see what it is here, so that you can execute these commands exactly like they're in these notes here, and they'll work for you. All right, we're just about done here with the first video. A couple more commands. There we go. PS, again, this is just standard Linux stuff, but I find them useful. This is all the processes that are running on this login node, and I like to grep it for my user ID because then that kind of tells me if I got any stray processes going. Here's my Vi session. That's the window over here. And then more standard stuff. If you want to see what the processors that are running, you can look at proc CPU info. I like to process that or filter that with a grep. And so that tells me that there are 32 nodes or 32 cores on this node, and they're running at 2.9 gigahertz. And you can find information about the memory on this node. If you want to just find out how big the node is, there it is. Alrighty, and then the other useful commands are like the batch system. So the way this machine is typically run is that people will get their source code, they'll compile it, they'll get some input data, and they'll create like a directory probably in Scratch, and they'll make a batch script, and they'll launch a job. And I'm going to give examples of that coming up. And there's a couple of different queues, and this QStat minus Q will give you an idea of how many jobs. So the CPU queue has 1,600 jobs in it right now, which is a lot. Amazing. And then QStat minus A will show you all the things that are running right now. All right, and then the last thing I want to do is kind of quickly go through what's called an interactive batch job. Some people like to actually kind of sit on a node and do commands, and because of the way the Cray is set up, you need to do everything through a batch command. But if you don't want to, you can start what's called an interactive batch job. And you need to get a sense of, there are 3 places. So right now we're sitting on an external login node, and when I start up this interactive batch job, Q sub minus capital I didn't give it any qualifiers, so I believe it's just going to give me one node, and we're going to have to wait for this to start up. There it goes. So what it's done is it's created a batch job, it's put it into the queue, and it's been scheduled like all the other jobs, and because it's so small, it got scheduled quickly. And I now have some resources, and if I pipe this for grep my username, you can see my job in the batch queue right here. So it looks like I got an hour of time. I got one node, and my batch job name is called standard in. Now I've now moved from the external login node to an internal login node, so I'm still not on the compute node. And if I actually want to, let's see. So if I want to find out what kind of nodes I have, this is the kind of processor I have. So the external login node had 32 core nodes, and this machine is using a 6-core processor. And let's see. So you can see the processors here. So I jumped ahead. You'll notice that if I issue a command without the AppRun, I'm going to get the login nodes information. But if I actually execute it with an AppRun command, the AppRun command is this thing that launches jobs to the compute nodes. That will then run the job. So that's how you can see the difference in the 2 outputs. So locally on the internal login node, I only have 6 cores, but on the compute node, I have 32 cores. Alrighty, and then I wanted to show you If you ever wanted to know where you're at in this machine or in a program, in the proc file, Cray has made a Cray XT directory, and it has a NID file, and that file just has one integer in it, and that's your node number. So this tells me that I am currently logged into a login node, and that's the actual login node, the number of it that I'm logged into. Now, if I launch a job, it's going to go to a compute node. So if I launch a job that says cat my NID number inside this job, that tells me that I'm on node 989 when my job executes. And because I'm inside a batch scheduler, I have been given this resource of one node, and for the duration of this session, I will always be on node 989. If I exited out of this interactive batch job and started a new one, there's a good chance I would land on some other compute node. Other useful commands is, if I do an AppRun command of my print working directory, it'll always put you in your home directory. And so you need to make sure that when you launch a job, that you always change to the correct directory where your executable and your input files are. All right, I'm going to exit this interactive batch job, and I'm going to call it quits for this first video. And I'll start another one in a few minutes here that'll talk about how to actually compile and run a job. Thank you.